In this video, we're going to use our knowledge of sine of x and cosine of x to find the graphs of secant of x, cosecant of x, tangent of x, and cotangent of x. Let's start with the secant. Well, we know that the secant is 1 over the cosine. So let's start by graphing the cosine. The cosine has a value of 1 when x is 0, and then the cosine is 0, then it's -1, then it's 0, then it's 1. If we move the opposite direction, we see the cosine alternate back and forth between -1 and 1. So the secant will be undefined wherever the cosine is 0. So we're going to put asymptotes here for the secant wherever the cosine has a value of 0. And then wherever the cosine has a value of 1, the secant will be 1 over 1, or just 1. Where the cosine has a value of -1, the secant will be 1 over -1, or -1. So these points that are maxes and mins on the cosine graph will also be points on the secant graph. Now let's think of one more value that might be helpful. Well, a nice value of the cosine is 1/2, and the cosine has a value of 1/2 when x is pi over 3. So that means that the secant will have a value of 2 when x equals pi over 3. So let's plot some points at pi over 2, 3, pi over 3, 2, and then all the other pi over 3 values, -pi over 3, 2, 2 pi over 3, -2, and so on. And then we see the general shape of the secant graph. Okay, next, let's look at the domain and range next, actually. So for secant, we see that it's defined for all x except where x is pi over 2 and any multiple of pi more or less than pi over 2. And the range of the secant, well, we see the secant starts down at -∞, comes up to -1, includes -1, then goes from 1 to infinity. And the period of the secant is the same as the period of cosine. It repeats itself after we've been through a full 2 pi. Okay, now let's look at the cosecant of x. Well, the cosecant is 1 over the sine, so we're going to do something similar. We're going to graph the sine. Then we're going to look at where the sine is 0. We know the cosecant is going to be undefined, so we're going to draw asymptotes wherever the sine is 0. Wherever the sine is 1 or -1, the cosecant will be that 1 or -1. And where the sine of x is 1/2, at x equals pi over 6, the cosecant is going to be 2. So we'll put in all our 2 and -2 points at the pi over 6 values. Then we have a shape of cosecant. And we'll look at the domain and range. Well, for the domain, we see the values that cosecant can't have are all of the multiples of pi. And the range is the same as the range of the secant function. And the period is also the same as the cosine, the secant, and the sine. It takes 2 pi before we see a repetition. Okay, let's move on to the tangent graph. Tangent is sine over cosine. We're going to use a similar method. We're not actually going to graph sine and cosine, but we're going to say wherever the cosine is 0, the tangent is going to be undefined. So we draw asymptotes everywhere the cosine is 0. Wherever the sine is 0, that's in the numerator of the tangent function, so the tangent will be 0 when the sine is 0. We'll put in all our zeros for the tangent function. Then we need Some other nice points. Well, we know that the tangent of x is 1 whenever the sine of x is equal to the cosine of x, and that happens at all of the pi over 4 angles. We get either 1 or negative 1. So let's put our 1's and negative 1's in at all the pi over 4 angles. And if we were to put in a few more points, we're not going to do it here, but we would see that the graph follows a shape like this. Notice that it does not flatten out as it passes through the x-axis. It's got some slope other than 0 as it passes through the x-axis. And there we have the tangent graph. Before we move on, let's look at the domain and range. So here we have all values of x are in the domain except when x is pi over 2 plus any multiple of pi. And the range, well, we see with the tangent function, it just goes from negative infinity to infinity. And the period is different here. We only need to go from negative pi over 2 to pi over 2 before we repeat. That's a distance of pi. Finally, we'll look at the cotangent function. Cotangent is cosine over sine. So we're going to put asymptotes wherever the sine is 0. And then the cotangent will equal 0 whenever the cosine equals 0. And like the tangent, we're going to get 1's and negative 1's when x is a multiple of pi over 4. Other than things that are also multiples of pi over 2. And we get a similar shape, not flattening out as we pass through the axis. The domain is all reals except for the multiples of pi, integer multiples of pi. The range is all reals, and the period, like with the tangent function, is pi. And there we have it.